You know that moment when your phone's hitting like 1% and you absolutely need to plug it in right now?
Oh, yeah. Or you're in a game, about to win, and the console's just like screaming for power.
Exactly. Or even just, boiling the kettle for tea in the morning. Simple stuff.
Mm-hmm. But all those things, they all run on energy. We kind of take it for granted sometimes.
We really do. And today, we're going to dive into where a huge chunk of that energy actually comes from.
That's right. We're looking at non-renewable energy sources. Think of it as the power behind the scenes inspired by physics in motion.
Okay, non-renewable. Let's unpack that. Sounds like it's stuff we can't just get more of easily.
Precisely. They're natural resources, but there's a limited amount, a finite supply.
Finite.
And we use them up way, way faster than nature can ever replace them. Think about like a super rare item in a game. Once it's gone.
It's gone. Or you're grinding for ages trying to find another one.
Exactly, that limited nature is key. So for this, we've looked at textbooks, Khan Academy videos, info from the U.S. Energy Information Administration, a bunch of stuff.
Yeah.
And the mission really is to figure out what these non-renewables are, where they came from, their origin story.
Like a superhero origin story.
Sort of, but for energy.
Mm-hmm.
And why they matter, and how they connect to things you see in movies or games. Keep it pretty straightforward.
Cool. Yeah. No pop quizzes then.
No promises. But the main idea, non-renewable means limited, can't be replaced quickly.
Got it.
And the big ones are, fossil fuels. You've got your oil, natural gas, coal, and then there's nuclear energy, which uses uranium.
Fossil fuel. Okay, the name itself sounds kind of ancient, right? Like digging up dinosaurs or something?
Well, you're not far off. They are ancient, formed over millions and millions of years.
Millions? Seriously?
Yeah, from the remains of stuff that lived a long, long time ago. Think tiny ocean creatures, massive prehistoric plants.
Yeah.
They died, got buried under layers of mud, rock, sand, and then intense heat and pressure deep underground slowly transformed them into these fuels.
So the gas in my dad's car started out as ancient sea goo millions of years ago.
Pretty much. It's energy captured way back, maybe during the Carboniferous period, hundreds of millions of years ago.
Carboniferous. Sounds important.
It was a time with lots of lush plant life. Here's the really cool part. The energy in those fossil fuels, it originally came from the sun.
From the sun how?
Photosynthesis. Those ancient plants and algae used sunlight to grow, storing the sun's energy. That energy got locked away when they died and eventually became fuel.
So,
yeah,
we're basically running stuff on super ancient buried sunlight. That's actually a pretty epic backstory. Way better than some game lore I know.
It really is. Okay, so let's break down these fossil fuels a bit. First up, oil, petroleum.
Right, the black gold stuff.
Yep. It's a liquid, a mix of hydrocarbons, basically molecules of hydrogen and carbon, mostly formed from those tiny ocean organisms.
And we use it for, pretty much everything, it feels like.
A lot, definitely. Gasoline, diesel fuel for cars, trucks, planes, but also it's crucial for making plastics. All sorts of plastic.
Didn't really think about the plastic connection.
Yeah, it's huge, and people have used crude oil for ages. Some think it might have been part of that legendary Greek fire weapon.
Whoa, ancient flamethrowers. That's intense, but oil? There's the whole spill issue too, right? That always looks awful.
That's a major downside. Oil spills are devastating for ecosystems, for wildlife. Think about those post-apocalyptic movies where everyone's fighting over the last drops of fuel.
Yeah, or everything's just ruined because of some environmental disaster. It reflects that risk.
It does. Okay, next.
Coal, the solid stuff.
Yep.
Black, sometimes shiny, sometimes dusty.
That's the one. Formed mainly from giant ferns, trees, swampy plants from millions of years back.
Okay.
And over time, pressure turned this plant gunk into different stages. Peat, then lignite, bituminous coal, and finally anthracite.
Whoa, levels. Like leveling up in a game.
Kind of, and each level, especially towards anthracite, got squeezed harder and harder, packing in more energy, more pressure, more power potential.
Makes sense. More squish equals more boom. What's coal mostly used for?
Primarily making electricity. Huge amounts of coal are burned in power plants, also for industrial heat, and sometimes heating or cooking.
Right. But coal's got a bad rep for pollution, doesn't it?
It does. It releases the most pollution of the fossil fuels when burned. You get sulfur dioxide, think acid rain, nitrogen oxide smog, tiny particles that are bad for your lungs.
Yikes.
And, of course, a whole lot of carbon dioxide, CO2, which is the main driver of climate change.
Yeah, you see that in movie set in, like, the Industrial Revolution. Or even some games, those big factories pumping out smoke. It definitely looks polluting.
It paints an accurate picture of some of the impacts. Okay, third fossil fuel, natural gas.
Natural gas, that's invisible, right?
Yep, it's mostly methane, plus some other gases. Colorless, odorless.
Wait, odorless. But I thought gas leaks smelled like rotten eggs.
Good point. They add that smell, a chemical called mercaptan, specifically so we can detect leaks. Safety measure.
Ah, clever. Smart. Where does it come from?
Often found alongside oil deposits, trapped in rock formations. We use it a lot. Generating electricity, heating homes, cooking. It's very common.
Okay. Any cool historical facts like Greek fire?
Actually, yeah. Ancient China, thousands of years ago, apparently used pipelines made of bamboo to transport natural gas they found seeping out of the ground.
Bamboo pipelines?
Yeah.
No way. That's seriously cool. How does it stack up environmentally? Better than coal?
Generally, yes. It burns cleaner than oil and definitely cleaner than coal, produces less of those air pollutants like sulfur dioxide and less CO2 per unit of energy.
So still a fossil fuel, still releases CO2, but less bad.
That's a fair way to put it. It's often seen as a bridge fuel for that reason. You don't see it visually in movies as much maybe, but it's powering the background of tons of modern settings.
Okay, so summing up fossil fuels, super important for energy, ancient origins from buried sunlight. But burning them causes pollution, contributes big time to climate change with CO2, oil spills are a risk, and we're going to run out eventually.
That nails it. Burning them gives us the energy, yes, but also water vapor and that problematic CO2. Plus the acid rain, smog components, and yeah, it's finite. A one-way ticket, as one source put it.
A one-way ticket. Okay, so that covers fossil fuels. What about the other big non-renewable? Nuclear. Sounds kind of sci-fi.
It does have that vibe. Nuclear power doesn't burn anything. Instead, it uses the specific element, usually uranium.
Uranium. Heard of it. Radioactive, right?
Exactly. Inside a power plant, they split the very center of uranium atoms, the nucleus. That process is called nuclear fission.
Splitting atoms?
And splitting them releases a massive amount of energy from just a tiny bit of uranium.
How massive are we talking? Like, compared to coal?
Huge difference. Get this. 1 kilogram of uranium can produce something like 24 million kilowatt hours of energy. 1 kilogram of coal, maybe 8.
Whoa. Okay, that's a mind-blowing difference. It's like comparing a firecracker to a bomb.
In energy terms, yeah. And a big plus. The process itself doesn't produce air pollution like burning fossil fuels does. No CO2 emissions, just steam, really.
Okay, so tons of power, no direct air pollution. Sounds amazing. What's the catch? There's got to be a catch.
There are definitely significant challenges. First, uranium itself is mined from the earth, and there's a limited amount, so it is non-renewable.
Right, okay. Still finite. What else?
The big one is radioactive waste. The fission process creates byproducts that are highly radioactive and dangerous for a very, very long time.
So what do you do with that stuff?
That's the million-dollar question. It needs incredibly secure, long-term storage away from people and the environment. It's a major challenge.
I bet. Okay, any other catches?
Well, there's the risk of accidents. While modern plants have many safety features, accidents can happen and they could release harmful radiation. Chernobyl is the most infamous example.
Yeah, Chernobyl, you hear about that. So powerful, clean air-wise, but radioactive waste and accident risk.
That's the trade-off. In movies and games, you see both sides, right? Sometimes it's the clean power source for a futuristic city.
Or it's the source of a meltdown, or creates radioactive mutants in a wasteland game.
Exactly. It captures that duality, immense power, but also potential danger.
Okay, so we have fossil fuels and nuclear. How much do we actually rely on these non-renewable sources overall?
Hugely. If you look at the whole world or just the US, something like 80 to 85% of all the energy we consume still comes from these non-renewable sources: petroleum, natural gas, coal, and nuclear combined.
80 to 85%. Wow, that's most of it.
It really is. We are heavily dependent on them right now.
So what about the other stuff like solar panels and wind turbines?
Yeah, the renewables. Solar, wind, hydropower, geothermal, biomass. Those are resources that replenish naturally. They're becoming more important, and there's a big push to integrate them more.
That sounds like a whole other deep dive, maybe.
Definitely could be. For now, the key is understanding this non-renewable foundation we're currently built on.
Right. Okay, so let's try and wrap this up. The main takeaways for non-renewable energy.
Okay, number 1, non-renewable means limited supply, can't be replaced quickly.
Check.
Number 2, fossil fuels, oil, gas, coal, come from ancient life, give us most of our energy, but burning them causes pollution and climate change via CO2.
Got it.
Number 3, nuclear power uses uranium fission for massive energy without air pollution or CO2, but it's still non-renewable, creates dangerous radioactive waste, and carries accident risks.
Perfect summary. So, thinking about all that, the fact that they're limited, the pollution, the waste, what do you think are the biggest hurdles for us, like humanity, in figuring out our energy future?
That's a huge question. Managing that transition away from something we rely on so heavily, it's complex.
And maybe thinking about games and movies again. How well do you think they show the reality of where energy comes from, especially these non-renewables we've talked about? Did they get it right, or just use it as a plot device?
Interesting things to chew on, right? Thinking about where your own energy use fits into this bigger picture, it really does connect back to that phone needing a charge or booting up your console.
Absolutely, makes you think.
It does.
All right, well, this has been super insightful. And hey, finally, a big shout out to the Geeky Gamer Science teacher for creating physics in motion and letting us do this deep dive.